Good morning, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. In this particular video lecture series, I'm going to explain about digital communication, mainly the baseband transmission. Under baseband transmission, I'm going to explain about line codes. Line code is the code which is used for the data transmission of a digital signal over a transmission line. This process of coding is chosen so as to avoid overlap and distortion of signals such as intersymbol interference. Line codes are used commonly in computer communication networks over the short distances. Line coding is a process of converting digital data to digital signals. By this technique, we convert a sequence of bits to a digital signal. At the sender, at the sender side, this digital data are encoded into the digital signal, and at the receiver side, the digital data are recreated by decoding the digital signal. There are various types of line coding techniques. It mainly deals with unipolar, polar, bipolar, multi-level and the multi-transition. Under each division will be having non-return to zero and return to zero types. So unipolar NRZ is nothing but non-return to zero, and RZ is nothing but return to zero. And bipolar in bipolar also will be having one will be having only an RZ, will be call it as a AMI index. The first one is unipolar. In this, all the signal levels are either above or below the axis, so it uses more power compared to polar. The first signal is the clock signal, which we are giving as one of the input, and we are giving the data as 10 100 111 So while representing it in unipolar NRZ form, it completely deals with only the positive cycle, because it is the name. From the name itself, we can define unipolar as nothing but it deals with only the one polarity. So only positive polarity it will be there. So if in case of 1, it will be high. If it is 0, it is completely 0. Likewise, the data is represented as shown in the diagram. Then next one is polar. Here the voltage will be on both side of the axis. Polar, where it deals with both the positive and the negative polarity. As usual, the clock is given, then the data in polar NRZ. First, for 1, it will be completely in the upper part. For 0, it is 0, and in the next part is 1. So it uses the positive polarity, and for 0, it is completely 0. Then polar RZ. Uh, from the name itself, we can define that it is a return to 0. So every pulse has to return to 0. So the first, if we have 1, the first in the first half cycle, it will be in the positive part. Then in the negative cycle, it has to return to 0. So we call it as a return to 0. It is represented in the diagram. Then for 0, we have to start the pulse from the 0, and we have to end it with the positive cycle. We have to start with the negative and end with the positive cycle. That is how we have to represent for 0. But for 1, we have to represent using first positive and then to the negative. Then bipolar. Here there are 3 voltage levels are used, that is positive, negative and 0. The voltage level for one data element is at 0, while the voltage level for other element alternates between positive and the negative as shown in the diagram. For bipolar NRZ, we should not return to 0, that is non-return to 0. So in case of 1, it is in the positive polarity, for 0 it is 0. Then for again 1, we have to start the transition alternatively. Say, then for bipolar RZ, we have to return the particular cycle to 0. So in first cycle, the positive part is the half has to be in the positive and remaining has to be in the negative. This is what bipolar RZ and NRZ. These are the various line codes represented in the single diagram. Whereas in case of Manchester, if it is 1, we have to start the pulse in 1, and in 0 we have to start it at the negative cycle. These are the various properties of line codes. For a given bandwidth, the power is efficiently used and the timing content is adequate here. Long strings of ones and zeros is avoided to maintain the transparency. Then the power density is much favorable. Then it is self-synchronizing, that is both receiver and sender clock should be synchronized. Then the complexity is less here. Then no low frequency component as long distance transfer is not feasible for a low frequency component signal. Assessment, the properties of line code and what is meant by Manchester coding. Thank you.